sound. You get a nice big spike for the camera. I've done the results for this two ways. I've done a approximations one, and then I've got one which has been done all properly with the calculator. Now what I intend to do is to go through doing the approximations one first. Because, you know, if you think about approximations and you're working to rough figures and you've got multiple choice, it allows you to go through the questions very quickly. So you can quickly populate. In this quiz we had 1, 2, 3, 4, 5 multiple choice questions. And if you can go through those 5 questions quickly with approximations, then spend more time on the worked problems, then you can go back through with your calculator if you've got time and do more accurate answers for the multiple choice. And especially if you've got multiple choice question like the first one, which was, the answers were 6 milliamps, 12 milliamps in round terms, 2.7 milliamps, 5.3 milliamps. You've got such a big difference between each one that you should be able to, with a guess, go it's A, B, C or D. And it's not so much guess is probably the wrong word. That's a strong word, but if you're spending the time to sort of break each part of the question down, you're coming up with something better than a guess, I think. Okay, first question. First question, we had 24 volts. We had 1K. 4.7K, 3.3K, 2.2K, and then we had 1.2K, and then we had a closed switch across this resistance here. One of the first things I did on my approximation circuit, I got a pen and I circled that and I just went closed like that. So then I know I'm only working with 1.2K. Just remind myself what I've got in front of me. And then adding these up, because I know that I've got a series parallel circuit here to work with. So 4.7K, 3.3K, what have we got? 7, 8K, 10.2K is it? Oops, sorry, I got a mistake there. That was 1K. So 4.7, 1K, 2.2, that's better. They add up to 6.9K. And that's in parallel with just the 1.2K. And then if I bracket that, because we can't forget this one here, plus 1K. Now, this is where the fun comes in, because I don't go for the calculator straight away. I've said 6.9K in parallel with 1.2K. It's around about, at a guess, it's about 900 ohms. Because I've got, you know, call that 1,000 ohms, call that 7,000 ohms. 7,000 ohms in parallel with 1,000 ohms. If it was 1,000 in parallel with 1,000, it'd be 500 ohms. So 7 to 1 is quite high. I'm going to estimate it's around about 900 ohms plus the 1K. That's going to give me 1,900 ohms. Still approximate. And 24 divided by that 1,900. I'll have to be a bit careful here. I know on the camera I'm probably about here, so I'll probably just wipe some of that off. It's all right, I won't do that on the next slide. And that's for the current, the total current. It was asking for the total current in this circuit. The total current I worked out to about 12.6 milliamps. And that, again, it's only an approximation. So the answers that we had were like 6.2, 11.7, 2.7, 5.3. You know, A, B, C, D. So it had to be this one here. And when I went back through it again afterwards and I did it correctly, I found out that the sums should have been more like, instead of 24 over 1900, it worked out to be around about 24 over 1960. So I was only out by 60 ohms. And that 60 ohms would have brought it back down to exactly 11.76 milliamps, which is exactly B. So just showing there, you can do it with approximations first, and then you can go on and you can do it with your calculator. And if you've done it both ways, and you know you're in the ballpark the first time, and then you've got the exact answer the second time, hey, how can you go wrong? You're proving to yourself that you know how to do the question, and that's what it's all about. Are there any questions about that first one? Okay, let's get rid of that. Second question. 3 resistors in parallel. 270, 480, 750. We've got a voltage source over here, 24 volts. One more resistance here, 270 ohms. So again, if we work with approximations, 750, so I want the 2. Oh, it's okay, I'll come back in the other way. 480, 750, 270. All right, these two are going to break down to give me around about 380 ohms. It's going to be in parallel with the 270. And that's going to give me around about 180 ohms. 180 ohms for that network there. And that 180 has to be added to the 270. Plus 270 will give me 450 ohms. And once I've got the 450 ohms, I can work out that IT is going to be 53 milliamps. And of course that IT is going to be 24 divided by the 450 ohms. That's how I got that 53 milliamps. So I've got 53 milliamps of current flowing in the circuit. 53 milliamps, and the question says the current flowing through the 480 ohm resistor. Well, that's that resistor there. So to do that, we need to think about the REQ. REQ of those we worked out was around about 380 ohms. And then it's always the REQ divided by the resistor you want to find, the current through times the current going into the network. Current going into the network is 53 milliamps. 380 divided by the 480 ohm resistor is what we're looking at, times 53 milliamps, and that gave me 19.8 milliamps. And again, I'm working with some approximations here because this 380, 180, that's only an approximation. But that was a good enough approximation to give me, I worked it out to about 19.8 milliamps. And then when I look at the answers, I've got a choice of 48, 17, 10.9, call it 11, and then 30. So there's only one which is close to that, and that was answer B, and that's the 17 milliamps. Once I go and I look at the calculator and I do the working out more correctly, I find that I haven't got 53 milliamps. In fact, I should have been working with around about 58.5 milliamps. And that would have been based on, my 380 would have been slightly wrong. I think it worked out to more like 410, something like that. So I was out by a little bit, but enough to get me into the ballpark for a multiple choice answer. Are there any questions about doing that? Straightforward? Well, if it's so easy, guys, how come you couldn't do it in the test? Where did you go wrong? Tash, did you get that one right? Yes? No? You got the same working out, but you still didn't come up with the same answer. Maybe you've still got a problem with working out the branch current in a parallel network like this one here. Anyway, we've got more to do. We've got the next question, which is not quite the same. It's got two branches instead of 3 again. So let's go on and do the next question. Does anybody want me to do anything more on that? All good? Okay. All right, the next question, 24 volts. $1K, 4.7, 5.6, 2.2. And then we've got in parallel with that a 5.6K and a 3.3K. Where's the, 1.2K at the top, thank you. $1.2, 3.3. And this one has a switch across it, but the switch is open. So we can just ignore the switch, and therefore we've still got the full resistance, 3.3K. Okay, let's see if we can work this out then. We've got to add up the first network there. So we've got 4.7, 4 and 5 is 9, 9.7, what's that? 10.3, 11, 12.3, 12.5K. 12.5K here. And then, because the switch is open, we've got to take both resistors. So 1.2, 3.3, what's that? 4.5K. So it's 12.5K in parallel with 4.5K. And then we've still got the 1K. So those two plus 1K. Again, approximation, I've said it's around about 3.6K plus that 1K, plus 1K. So that's about 4.6K. And the question was asking for the current in resistor 5. Resistor 5 is this one here. So we know that we've got a current split, we've got the total circuit current, and then we've got some current coming down through here, and we've got some current going down through there. The current going through that and that are going to be the same, so it's going to be the current going down through the 4.5K branch. And they're going to share that current because they're in series. So what we can do then, we've got the REQ of 3.6K. Again, it's going to be REQ over the resistance in question times IT. We need to find IT. IT is going to be using this 24 divided by 4.6K. And I think I worked out that was, oh, maybe I didn't work it out. (24 divided by 4600), 5.2 milliamps. So that 5.2 milliamps is what's flowing totally in the circuit, 5.2 milliamps, and then that 5.2 milliamps has to split. The path with the smallest resistance is going to have the greatest current going through it. 12.5K there, 4.5K there. This branch is going to have the bulk of the current, and there's around about 2 to 1 ratio here. That'll have 2/3 of the current going down through that branch. So let's run the maths on that then. We need the REQ, which is 3.6K, divided by the 4.5K times 5.2 milliamps times 3600 divided by, whoops, 4500, 4.17 milliamps. Coming down through here. And again, that was a approximated value. I look at the answers and I end up with answer A was 5.48, then a 3.22, 8.71, 4.1 milliamps. So approximation 4.17 milliamps. It had to be answer D. And then if you do it using the calculator for all of the parts, you'll get exactly the 4.1 milliamps, of course. Are there any questions about that problem? That was question number 3. Who got that one wrong? A lot of you got it wrong. Can you see where you got it wrong? Ethan, where did you go wrong with it? Oh, look, get into the habit of putting circles around things. You know, if the question's asking for the current through R5 in that case, do a nice current arrow next to it, put a circle around it like, you know, asterisk. This is the one that we need here. You know, it's no good just thinking about the 5.2 because, hey, guess what? That one of the answers there was, you know, a little bit more than that, 5.4 milliamps. So if you read the question wrong, did you put answer A? Yeah, you went for answer A. Yeah. You've got to be so careful. All right. Any other questions about this one here? The next one is based on the work that we did on the Wheatstone Bridge. because the Wheatstone bridge is only two sets of resistances that are in parallel but split in the middle. Remember, we looked at in class how it can be drawn several different ways, and in this case we're looking at the voltage between 2 points, and we've got 12k and we've got 10k, and over on this side we've got some quite small value resistors, 480, 750 and 270 ohms. Now, I tried doing approximations on this and it was an abysmal failure because the answers are too close together for an approximation to work. Basically, I looked at these and I said 480 and 750. I ran just an approximation on that and I called it 320 ohms, and then I had 270. I suppose we'd better look at the voltage that we've got supplied to this. We've got 24 volts. So to run the voltage across there, you could do it using the ratio method, but I did it using the current and then multiplying the current by the bottom resistor. So the current in this bottom branch, or this branch here, is independent to the current in this branch here. I've got a total current flowing, don't have to work that out in this situation. I only need to find the voltage across that resistor and the voltage across that resistor and then subtract one from the other. So to find the voltage across that, it's going to be a case of finding the total current travelling down through that path and then multiplying the current times that, because V equals I times R. So 320 plus 270, 320 plus 270, what's that going to be? 590. So it'd be 24 divided by 590 times 270 ohms. And I did that and I got 10.98, I think it was, volts. 10.98 volts at that point there. And again, that's based on an approximation. And this approximation, you'll see in a minute, it's not going to work out for me. 9 times out of 10 it does, but this one won't. A little bit sad about that. On this side of the circuit, the current travelling down through here, I've got 22k. So it'd be 24 divided by 22k gives me the current travelling down through there, and then V equals I times R, multiply the current times that resistance times 10k, and that gives me 10.9 volts at this point here. 10.98 minus 10.9, I get 80 millivolts. I look at the answer, all excited about 80 millivolts, and I go, uh-oh, didn't work out. So I know that side's correct because I did it with the calculator. It's exactly 10.9 volts. But this one here, I estimated this. So when I went back in with the calculator and I worked it out, and I'll do it in red here, it was 293 ohms. Not 320. Not much difference between them, but in this case it makes a big, big difference. So I had to run the maths again. I had to go the 293 plus the 270, which was here, to give me, what's that, 563. 24 divided by 563, total resistance to give me the total current in that network, and then multiply that current, V equals I times R, times the 270, and that comes out to be 11.5 volts. And then the 11.5 Now we can go 11.5 minus the 10.9 on this side, and we get 600 millivolts in round terms. 607 millivolts. Who got that question right? I know 2 others got it right, so only 3 people got it right. Yeah. Okay. Can you see now where it was wrong? Can you see what you did wrong? You've got to treat the networks independently. You've got a voltage source, you've got current that splits, and some current comes down through here, some current comes down through here. Once you've got a current, you've got a resistance, you can work out a voltage. So you can work out the voltage across that, you can work out the voltage across that, minus 1 from the other. But in blue here, my approximations for this question were a total failure. That happens sometimes, and that's just the way it goes. If the questions, if we'd had larger resistance values here in this case, it would have worked out for me, but the resistance values are quite critical in this question. No other questions about that? All right, watching the time, I know we're going over time a little bit. The next question, it's got a voltage that you're given of 12.5 volts across a resistor. I'm not worried about what the resistance is because that resistor is just at the front of a network that we need to solve. And because I know the voltage, if I know that resistance and that resistance, I can work out the current which is travelling through this part of the circuit. And we do in fact have some values. That's 100 ohms, that's 20 ohms, that's 80, and this is 150 ohms. 20 and 80 adds up to be 100. 100 in parallel with 100. We saw this in a question last week, similar question. Equals 50 ohms, 50 plus 150, 200 ohms, 12.5 volts. IT equals 12.5 divided by 200 equals 62.5 milliamps. And I think a lot of people left the answer at that and didn't go any further. Well, that's not right because the question said calculate the current in R5. R5 is this critter here. We want the current travelling through just him. If we know we've got 62.5, that's the total current. And that current splits. So some comes through here and some comes through here. We need the REQ for that. The REQ for that is 50 ohms. REQ over X times IT. So it'll be 50 divided by 100 times 62.5. That's going to be a half of 62.5 to give us 31.25 milliamps of current travelling through this part of this network because the current splits and some goes that way, some goes that way. 100 ohms, 100 ohms, the split's simple, half goes through each part of the network because they're the same resistance. The voltage across R5, V equals IR. This is one of those questions where unfortunately if you get the first part wrong, the second part's going to be wrong too. So you had to get the 31.25 milliamps and you had to multiply it by 80 ohms. And that gave 2.5 volts. And that's the answer for that question. I know a lot of people got that one wrong too. More than half the class got that one wrong. So there's nothing new about the question. It's just taking exactly what we've seen in each other question all the time, working with current divider and working out how much current's going through each part of the network. If you can't do that, you really need to learn how to do that. All right, look, we'll stop there and we'll take a break, and then I'll do the next two after we come back from the break, and then we'll move on with capacitors. Any questions about that before I finish it? Okay. See you after the break. All right, so we're up to question 7 in the quiz now, and question 7, not too dissimilar to the other questions, but probably one of the easiest questions in the whole paper. Had a 4.7K resistor here. .3K resistor down here. Drawn a bit weird, had a 1K resistor here. And sort of something like that. Had another 1K resistor here, and you had a milliamp meter, and then you had a supply voltage of 18 volts in this case. 18 volts, and the question says the current showing on the meter will be. So, whoops, I looked at that and I said, that's got to be a bit of a gift of a question, because there was no branch currents involved in this. It was merely work out the whole current for the circuit, and that gives you the answer for the question. So just again some approximations here, or did I even need to? 4, 7, 8K, and then I've taught you how to loop these things before. That was in fact 2K. And then that would be 8 in parallel with 2. So 8K in parallel with 2K. An approximation, I called it about 1500 ohms, about 1.5K approximation. You've got 18 volts, so IT equals 18 over that REQ. Equals 18 over 1500, and that gave me 12 milliamps. And the answers to choose from were like 4.7, 11, 9, or 3. So with an approximation even, 12, there's only like one that it could be close to. The 9 you might have to have a bit of a think about, because if I'd been in error too much on the low side or too much on the high side with my resistance, I might have gone closer to the 9, but probably not, because the answer was 11.25 and I'm at 12. I think I'm pretty safe with that. When I did it on the calculator, I think it worked out to, yeah, it worked out to 1600 ohms. I'd approximated 1500 ohms, so I was pretty right for that. Any questions on that one? It was really a gift of a question. I hope more people got that one right. That's a fairly straightforward question, and all of these questions you've done, you can fully expect to see these in other tests. Especially today, we're moving on from series parallel to capacitors. They'll go away for a little while, but then in 2 weeks' time, they're going to be back in your face again in your final test. Okay to take that off the board? No questions? All right, well, we're up to the last question, and the last question was a question about breadboards and taking a picture from a breadboard, and I'll put that into the video separately, because it's a little bit hard to draw it up on the board. What I will do, I'll just put my scratchings up on the board. I started here on the left-hand side of the page and I wrote in and I put a big A there like that. Why? Because on the question at hand, it had A, B for the 2 voltage connection points. It said in the question that all resistors equal 220 ohms. So it came in through the first resistor was R2. I didn't find an R1. Oh, yes, I did. I did find an R1. I found it later. R2. Then I found an R6. And then I found an R5. How did I find them? I was just going, following the links on the SK10 breadboard from the end of one resistor to the next and making sure that there was no parallel circuit going to something else. R5 to R4, and when we got to the end of R4 there was a split. So when there's a split with a circuit, I like to take a 90-degree sort of a function with 2 axes on my drawing to let me know there is a split, and that was R3, and I put a big arrow there, and that was B. B was the output shown on the question, and then R1. Ooh, R1. Remember, we started with R2 and I said, where's R1? And R1 comes all the way back here to that point there. So I guess I hadn't seen that when I started the question, otherwise I would have had a definite y-axis coming off that on my drawing to indicate that there was a branch there. But I caught up with it at the end over here. All 220, so I've got 880 ohms. I've got 220 ohms here, so I've got 880 in parallel with 220. I estimated that's going to be around about 190 ohms, or I might have done it with the calculator, I can't remember now. 190. I'll show it here as an approximation. Add the 220, don't forget this, that's 220 ohms on the output, so 880 in parallel with 220, added to 220. Maybe I'll do that, showing that 220 there is the very last resistor, R3. That gave me 410 ohms, and then to get the next part of the question said that I had 10 volts between A and B. $10 volts, 10 divided by 410 ohms to give me IT. And then I think we had to work out the current in R2. Ooh, just this resistor here by itself. We had to work out the current. But the fact is, he's in series with him and him and him, so the current in that is the same as that, that and that. But the current through here is different, and the current through here is different, because that's the total current, IT. And IT worked out to be 24.3 milliamps. $24.3 milliamps. And then the REQ, which was the 190, because we've got a current divider here, haven't we? Current coming in is positive. Some going that way, some going that way. So REQ is put up here, REQ over X times IT. So that'll be 190 divided by 880. I can't just take the 220, I've got to take everything in that path because the currents split here and then they merge again over here to make the output current. If 24.3 comes in, 24.3 has to come back out at that point there, but we've got a split in the middle. 220, more current's going to go through this branch than that branch. This one's going to be the smaller current. 190 on 880 times 24.3, and that worked out to give me 5.26 milliamps. Again, I'm not sure whether that was an approximation or not. It's in blue. Usually things I do in blue on paperwork are an approximation. That's just the way I do things. If it's done with a calculator, it's usually with a black pen or an orange pen. Was that right? Was that the approximation? What was the answer that you guys got? 505. Okay, so it was an approximation. 5.05 milliamps, 5.26 milliamps. Look, if you'd used approximations and you'd done your circuit that way on the back of the page, I would have given you full marks for it. No problems about it, because you've proven that you know how to do the question. That's the main thing. Let's not split hairs over 20 milliamps in the circuit, or even less, 20 microamps in the circuit. Let's not split hairs over that. Any questions about this? It was another one of those double barrel questions. You had to actually go from the SK10 breadboard layout to be able to construct the circuit. Those of you doing the soldering class, we do this in the soldering class as well. Going from breadboard to circuit to Vero board layout, we do in that class. In here, in DC, and in the AC class which follows, we'll be going a lot from breadboard design, SK10 to circuit, and backwards and forwards. It's a very important concept that you must understand with electronics. All right, that wraps up the quiz for today. Any comments about the quiz questions, or especially about this one I've got on the board before I rub it off? R2 and R1 in parallel. No, if R1 and R2 were in parallel, they would have had to, on the breadboard, have actually ended up like that. And if you look at R2 on your breadboard layout in the question, and you just take one end of that resistor, one end of that, see if you can locate R1 pin for pin sitting across it, and you can't. Yeah, so it's definitely not in parallel with it, yeah. Any other questions?